Okay, let me proceed with this one. Nowadays, everyone is familiar with the lift. I'll take example of lift to explain this particular concept here. So there's a lift. There's a pendulum of mass m. So mass of the pendulum, let it be 2 kg. Lift, let it, initially, what is the state of lift? Lift, let it be at rest. There are two persons are there, person P and other person inside the lift, let me call Q. Okay, now where is the person P? Person P is on ground. So what shall I call him? Inertial frame? Yes, no. So what he says that the tension will act here. So I'll show the force. Tension, and this is mg. So what is the tension? So how much of tension measured by the person P? So what you say that what big comment from him? Block is at rest, or the Bob is at rest, and you will write equation T minus mg equals 0, and how much of tension you will write? T into 2 into 10 equal 0. Tension equal to how much? 20 Newton. Is that okay? Fine. And what about person Q? Person Q, you'll also comment same thing. Bob is at rest, and what are these equations will be? T minus let me put on this side so that Bob is at rest. Then what is the equation you write? T minus mg equals. You will also say that tension is 20 Newton. Nowadays we have mobile, so they'll call each other. How much you measure tension? 20 Newton. You'll say 20 Newton. Okay, fine. And both will say that yes, Bob is at rest. Okay, these are the comments. Okay, let the lift accelerate up now. Lift accelerates, and I'm showing that lift is in let the acceleration of the Bob be 3 meters per second square. So there's a person is there on the ground. And there's a different situation now. What is the state of lift? Lift is accelerating. There's a person P, and the person who is there inside, let it be Q. Now what person P will say is on the ground? Bob accelerates upwards. Is that okay now? So this will be the comment of that person. What he says, Bob accelerates up, that one. Then what are the things? So this will be the tension. And this will be the weight, mg. So what are the equations you'll write? Person P, what are the equations you'll write? T minus mg equal to ma, T minus 2 into 10, 2 into 3. So how much of tension? 26 Newton. I'll write it everything nearby him only. Very simple. Just you have to make observation here, nothing there. Bob accelerates upward. And how much of tension you'll measure? 26 Newton. So there's no problem with him. So we'll go for person Q. Now, what will be its comment? Bob is at rest, he says. Bob is at rest. Bob accelerates upward. The person Q will say Bob is the test. No? Then what happens? He'll measure tension. Here I think the real trouble will start. So what is the equation you write? P minus mg equal to 0. And in fact, he'll measure tension. And there'll be some instrument, spring balance, which will read the tension. So what is it that T is how much? 26 Newton. And what is mg? 20 Newton. Though tension greater than weight, but still what happened? He said the Bob is a test. I think there's some big problem is there, no? So here, what happened? So what was the condition? Why Bob is a test? Because net force 0, account of this person. What is the thing? Acceleration is 0 because F is 0. And here also same thing. Acceleration 0 because force is 0. What about here? Acceleration non-zero because the force is non-zero. What about here? What this person? What is the comment from what happened here? Though acceleration is 0, but force is non-zero. I think some big problem is there with the Newton's laws, no? Try to see this. There's no problem with the person P, no? Why Bob is moving? Because net force non-zero, that's why acceleration non-zero. Person Q is a big problem. What is telling? Though net force non-zero, but acceleration 0. What happened? Newton's law? Newton's law has become invalid. So what is the problem with him now? There's no problem actually. Yeah.
Sir, is it because of two different frames, sir?
Two different frames only. So now, shall we close the topic here only? The answer is okay, fine. So what are the forces acting on them? It just says that T minus mg, that's all. And still it is a test. Okay, this is the major problem arises here. So now the person Q is the problem, no? So what is the person Q now? Person P is inertial frame. So definitely what I should call is an inertial frame. Is the inertial frame. What about person? Person Q is a non-inertial frame. So where do we encounter problems now? I think in the lift frame, there's a big headache, no? So writing equations of motion is a big problem. So we can't solve the problem. We have to just live it. So who is right? Is the person Q right or wrong? He just says tension greater than though force non-zero, but still the acceleration is 0. So Newton's law has become invalid. To make it valid, I am going to introduce a pseudo force. That's all here. So the same diagram I'll continue. So it's better what will happen whenever you get a problem. So where the with respect to person Q only, let me show this diagram. So here, what are the forces? The tension, weight mg. And the tension. Then one more force called like a pseudo force is what I'm going to introduce. Pseudo force, I'll take some orange color. Green color will take it. Thick arrow, I'm showing that one. So that is the pseudo force. Now there won't be problem for the person Q to write the equation. So what are the equations you will write? T minus mg minus ma equal to 0. Sir, how to take pseudo force? How to take that pseudo force? That pseudo force, what happened? You have to, what is the procedure you have to apply? I'll write it a little bit bold. How to take pseudo force opposite to accelerating frame. So what is a lift of the person is accelerating frame. Mass of the system into acceleration of non-inertial frame, and directed opposite to acceleration of non-inertial frame should be the pseudo force here. Now this is what the pseudo force. Now I think now the person will justify the answer. No, now this MA is what, like we are a person who is solving the problem is bringing this one. Person Q will not see this force. I'm making clear. A pseudo force should be taken opposite to direction of non-inertial frame. So lift is accelerating up. So therefore pseudo force should be opposite to acceleration of the lift here. MA downward. What is M? M, mass of the system into acceleration of non-inertial frame. And directed opposite to acceleration of non-inertial frame. What is A? Acceleration of non-inertial frame. So now this MA, what happen, will be seen by person Q? No, nothing. This is what happen. Person who is solving the problem is going to introduce this MA in non-inertial frame. In the ground frame, not needed. So will you get same answer? I think you look at once the equation T minus mg equal to ma, T minus mg minus ma. Mathematically, both are same, but in terms of the frame of reference, things are totally different here. This ma is not seen by Q. I'm making clear. Ma is what? Just introduced by the person who is solving the problem. What is the what is the net force acting on the bob account to person Q? T minus mg only. Okay, this I'll put a condition, that one pseudo force introduced by person solving the problem. Okay, fine. So these are the some very important conclusions which we have to make it here. Means like, sir, when to take pseudo force? When you take reference point non-inertial frame, take it. Sir, I'll do all the problems in ground frame. Okay, fine. Good. Say goodbye to pseudo force. Okay, so this is some brief introduction about the idea of pseudo force. So rest of everything is in different numericals. You have to see that how you work out in. Both the persons will measure same tension because we do have instrument. We do have instrument. That instrument will definitely tell us what is the tension. Both the persons will measure same tension. Okay, let me take you to the numericals.